Okay, cool. All right. Just want to do a sound check for Calgary before we get started here. Make sure they're tuned in. How about in Vancouver? Does this look like everybody? Are we still waiting for anyone? Cool. Just looking for a thumbs up from Calgary or something that they're on board. Am I on the right channel? Is this the right channel? Okay. Okay, great. So who knows what we're talking about today? Errors? How did you know? Compass, okay. Um, yeah, so we're talking about errors today, and then we're going to talk a little bit about promises. This is sort of two lectures in one. And for a long time, I was kind of puzzling about how to fit those two things together. And I think they kind of don't. So we can treat this as like a first half, second half sort of thing. So we're going to start with errors. Who here has received an error before while programming? No, never? Never? Yeah, if you don't make mistakes, you never get errors, right? Um, yeah, we kind of run into errors probably the first time we try to do anything, right? Like if you come from a different programming language, you might jump into a JavaScript interpreter and try something like that, right? That doesn't work. This is not valid JavaScript, right? So we get an error, and the error tells us something about what went wrong, right? So in this case, what kind of error do we get? Syntax error? Yeah. Is this big enough for everybody? Okay, cool. Yeah, we get a syntax error. What's that mean? Pardon me? You didn't write it correctly, yeah. So in this case, this is invalid JavaScript. This is malformed JavaScript, right? So this error comes from the interpreter, and that's one place that errors can come from, is JavaScript itself goes, something's wrong, revisit your code. Where else do errors come from? Errors can be thrown, sure, yeah. What does it mean to throw an error? So So something happens in the logic of the code the developer's written that shouldn't have happened, and that throws an error. Um, yeah, that's one place that it can come from, is you did something wrong. But it's also possible for your library code to give you an error, right? If you use jQuery version 0.5 or something, it's very possible that you could be just coding along, doing everything right, and there was an error in their code, right? And being able to distinguish between this is my fault, this is their fault, this is what went wrong, is what makes errors really useful, right? So it used to be the case that if you were programming and something went wrong, you just get like this jumbled mess that came out. You just get some nonsense and have to kind of go like, oh yeah, that was supposed to be like a picture of a dog, and it's not. It's just like a bleh, like a mess of ink on the page if I'm printing out something on like a dot matrix printer or something, right? So do they? Unexpected effects of functional code. Interesting. Can you elaborate on what that means, Greg? Wonder if you heard me. Okay. Maybe just leave my Slack window over here. Seems like a good idea, right? Syntactically correct, but not working as intended. Yeah, exactly. So that's one of the things we're going to drill into in this lecture is when things are syntactically correct, they're technically valid JavaScript, but they don't do what we want, right? So in the example of getting like a big mess out on your printer page because you got some interpretation error and you didn't get the dog picture you wanted, we know that something went wrong, but we don't know what, right? So you can imagine a developer working on like printer drivers going, you know, it'd be nice if instead of just printing out a mess, we could give some more insight to the developer about what exactly is going wrong, right? So let's look at some code here. I'm gonna pull some code from my nowhere. I'm gonna write it from scratch. Okay. So let's imagine we have let's say we're writing like an upvote downvote system for a site like Reddit. Okay. We can imagine that we have some object that represents a post. Oops. Oh. What kind of error is that? Speaking of errors, right? Yeah, that's like an error with Atom. Some library I have, apparently JS hint, got confused about something. Actually, never seen that before. So we have, you know, an upvote, like a collection, not really a collection. We have a number of upvotes. Let's say a particular post has 40 upvotes. And we want to figure out the post score, right? What needs to go in here? How do we start with this and end up with a post score? So if we have 40 upvotes and 10 downvotes, then we expect to see the score for that post to be 30, right? So it's like the difference between the upvotes and downvotes. Maybe nobody here uses Reddit. Maybe this is jumping the gun a little bit. Does that make sense? So where does post score come from? You get the difference between these two properties, right? Yeah. So you can get those two properties by like we have the post that we're passing into the function. Christina says post score hasn't been defined. That's correct. We're going to write the code in the middle here that defines it so that we're returning the right thing. So what I did here, by the way, is I just wrote out the function signature, right? So the function signature is its name, it's the parameter it takes in, and it's the return value, right? So I always find that this is kind of a good place to start when you're trying to implement something. You define, this is what I have, this is what I want, and then you write the stuff in the middle, so that's what we're doing here. So post score hasn't been defined, we're about to define it. So you said that we want to get the properties on post. We expect post to have an upvotes property and a downvotes property. Does that make sense? We would expect to see 40 when we do this, right? And correspondingly, we get our downvotes this way, right? So I'm going to try some cool ES6 stuff. Tell me if this freaks you out or not. Has anyone seen this before? Is this like old news for everybody here, or is this like... Okay, cool, cool. So all I'm doing here is post D structures into, it looks at post.upvotes and it puts in a variable called upvotes, post.downvotes puts in a variable called downvotes. And now we can calculate our post score, right? How do we do that? Upvotes minus downvotes, exactly. So now we can return post score. And I'm going to simplify this a little bit and just return up here. Okay, so let's see if this works. Oops, it didn't work. Yeah. Oh yeah, nothing happened because I didn't console log. Yeah, so we got back 30, right? This is just the end of the file name. It just wrapped. So we got back 30. And that's what we expected. So how does everybody feel about what we did so far? This is kind of just a warm-up. We're not really talking about errors yet. It's just like JavaScript. Does everybody feel okay about this so far? Any questions so far? Okay, cool. So you can imagine that we take this function that calculates the upvotes and downvotes, and we're going to put it in our code somewhere, and a bunch of different things are going to use it, right? A bunch of different things need to know what the upvotes and downvotes are on a post, so it can do things like decide what's going to show up in your feed under different filters. You're going to want to like sort your own posts by score. So we're going to need to use this in a lot of places. It goes into the code, right? Now, the people who end up using a function like this aren't necessarily going to be looking at the source code for it, right? They're going to know that there exists a function called compute post score. They're not necessarily going to know that this is how it works on the inside, right? And they're not necessarily going to use it correctly. So we can end up with all sorts of things where like somebody just passes the upvotes along, somebody passes just a number, right? What other things could go wrong with this? The way someone uses this function. Pass in the wrong object. Sure, you might pass in, like what kind of object might you pass in by accident? Okay, yeah, you might pass in an empty object. This is especially true if you're making like an API call and it hasn't returned yet because you're not doing your asynchrony right, which you're going to talk about later. You end up passing an empty object. Yeah, this could end up being the wrong data type, right? All sorts of things could go wrong. So let's take, for example, this case where somebody has a string for upvotes and a number for downvotes, right? When I run this code again, what do we expect to happen? Pardon me? Be not a number. Any other ideas? Not a number? Let's see what happens. It's interesting. What's that? Yeah, is this a coercion thing? What's that going to do? That'll concatenate, yeah. So that's kind of weird that if you subtract a number from a string, it coerces the string into a number, and if you do adding, it coerces the number into a string, right? So this is the result we want, but kind of by accident, right? Because if this is a string, it could be any string, right? What's going to happen now? Now we get not a number as you predicted, right? So I think it's safe to say we don't want to pass a string to this function, right? So we might say we get our upvotes and downvotes out of the post object, and then we might say if upvotes or downvotes are not a string, I don't want this. I don't want, or sorry, are not a number. I don't want this code to continue. They have to be a number. So how might I approach that? You might have some tools at your disposal already that'll let you achieve this functionality, right? First thing we need to do is tell whether these things are numbers. Any ideas? Can you do type of? Looks like. Sure, yeah. If we do type of 10, we get number. Just make sure that if we do type of string 10, we don't get number. Cool. So then if we do this comparison, well, this returns true. So that looks like a good predicate for an if statement. Just going to make this full screen. Sorry, Calgary, I still know you're there. So I'm going to check if upvotes is not a number or downvotes is not a number, then what do I want to do? Throw in then some error message. Yeah. That was going to be the big twist in a few minutes. Yeah, what we're gonna do is throw, but without even knowing about throw, right? We could maybe do something like we could just return, right? Maybe we could return false to communicate that something went wrong, right? To further communicate that something went wrong, we might leave a friendly message. So now when we run this code, we get a message and we don't get a result that we can use as like a post score. Can false be interpreted as 0? False can be coerced into 0. I guess it depends what you mean. So yeah, you might have a contract with some other code that says if this is a number, then make that the post score. If it's anything other than a number, then it's not a valid post score. Just don't show the score, or something like that. But this is kind of weird anyway because like we're still returning something from the function, which kind of implies that it like went well, right? So that's where throw comes in. So you notice how return here is red, right? If is red, const is red, function is red. What do these red words mean? What does it mean for a word to be red? It's probably a different color in your text editor, but in mine it's red. What does that mean? What do the red words have in common? It's a bad example, actually. There we go. Right? What do these red words mean? Kate guesses they're a method. Not quite. They're not a method. They're JavaScript keywords. Can I get my window the right size? That's better. So these are JavaScript keywords. So a method can be anything. You can name it whatever you want, right? But keywords are reserved. It's like you can't go, or at least I hope you can't go. You can't use the word function because function's a keyword, right? You wouldn't want to overwrite the ability to declare functions. Like whatever you're doing, you don't want that. So when I replace return with throw, we see it turns red. So throw is a JavaScript keyword, which means it has like some special built-in functionality to it. So throw's behavior is throw indicates that if this line is run, if the code reaches this line, something's gone wrong and you should explode. Now, how far you explode depends on how you handle the error, where the error is handled. But the standard behavior is throw is kind of like it explodes all the way to the top level of the app, and then the app crashes. So we'll elaborate a little bit on that when we talk about error handling, but for now we'll talk about the mechanics of throw. So I messed this up. There we go. So instead of doing this console log, a console log is okay, but a developer might not see it, right? So instead of the console log, we're gonna go throw and then pass it a message. So now when we run this code, it looks a little different, right? If you compare that with the console log, with the console log example, we just get the message and we get the return value, which is kind of funny. The console log actually doesn't stop the code from running. If we have the return in there, it does stop this line from running, but the console log on its own doesn't have any such power, right, to interrupt the flow. But throw, on the other hand, stops the code in its tracks. And we get that there was an error, and we also get this. And what's this? Where the error occurred. Exactly. So we have a file path, which is great. And then we have, what's this? We have this guy. Any ideas? Line number, yeah. Yeah. So yeah, we can see on line 9, that's where my throw is. So that's kind of useful. If we go sleuthing to try to figure out what's going on here, then we know to start on line 9. And if I put like garbage in here, it would crash on line 9 for a different reason. Is that still big enough to see? Can y'all still read that? Okay. So this time I get, this isn't an error I threw, but we still get that the error occurred on line 9, right? But in this example, we also get a bunch of other stuff, right? So here we get, this is the same as when I threw the error earlier, But then what's all this stuff? What does all this mean? Yeah, so this is called the stack trace. Um, so apart from just the line number, like this is the line of code that exploded, we also get a reference to this happened while you were inside of compute post score. And this happened while you're inside of this. And this happened while you're inside of this. And basically from about here, as soon as you start seeing internal in the file path, that means that this is, the stack trace is like going into node land. So if you have an error related to something internal, you have bigger problems than just like your JavaScript is wrong. It's like probably your interpreter is corrupted or something. So usually what we care about is we look at the file path, and then when we stop seeing files that we recognize that we're in control of, we can stop looking for the bug there. Yeah, so this is kind of interesting. The reason we get this full stack trace with the garbage error is because this is not just we're not just throwing a string. In this example, we're just throwing a plain string. In this case, we're throwing a specific error object called a reference error, right? And we can throw our own errors. Have y'all seen the new keyword come up yet? Have we used new for anything yet? No? How about new date? Has anyone done one of those yet? Okay. So we use new to create a new object. When we have a class defined, or we have like we have an object that we can construct, we use new. So you'll see later when you learn about classes. You have some class like this, and then anytime I want an instance of this class, I go new. And JavaScript has a whole bunch of these built in. So we're going to look at new error. So now when I run this, we get the same thing, but it's not just a string anymore. It's actually an error object. And the error object comes with a stack trace. Does that make sense? Is anyone not clear on the difference between when we made it an error versus when we made it a string? Is there anything you can do with errors other than giving them a name or giving them a message? Right. Sure, yeah, you can give it a name. So you notice that when we have this kind of error, it's just called error. And when we do, this garbage, it's not just error anymore. It's a reference error. And this thinks that there's a variable when there's not. But I think if I do like, if I do that, I can get a syntax error. Right, so there are these different categories of errors built into JavaScript, and you can make your own. So we're not going to go into it too much because like you hardly ever do it when you're writing application code. If you're writing library code, you might want a really big system. You might want more sophisticated error handling. But yeah, you can actually create errors with like complex behavior and like their own names and things by creating a class that extends the error base class. That's like way beyond the scope of what we're going to talk about today. So yes, but Let's talk about this error message for a second. What do you think of this error message? It's technically correct. Okay, is it? It's not very descriptive. Yeah, yeah. It doesn't really say anything about what went wrong. It doesn't give any hints to the developer, right? So already what we've done is we've at least exposed that something went wrong and we've given a stack trace, right? And that's already pretty helpful. Let's run that again. Yeah, so it's already pretty helpful knowing that something bad happened in compute score and it happened on line 9. But it's good if we can give the person receiving the error, who might be you in the future, kind of more hints about what's going on. So how might we make this this error message better? Let's brainstorm some ideas. What could we write instead? Okay, the data input is not a number. Yeah, that's a big improvement over what we had before, right? So we've said that there's a problem with the input. We've said that the problem is related to the data type. And I would take that one step further. Just going to change this to a template string. I'd say I would say I got bad data. Here's what I got. So yeah, this message is great. I think my personal rules for like how to write good error messages are: a good error message should say where in the code the error happens, and we get that from the stack trace. It tells you what data was involved. In this case, the upvotes and downvotes. And it says what the problem was, which is what you covered with referring to the data types. The data type has to be number for both parameters. Let's see, I might, I might actually change this. I'm going to say the same thing in different words. I'm going to say input to actually don't love my phrasing there, but gets the job done. So here I'm flagging a little more explicitly that it's the input to the function that was a problem. Said the input must be an object, it must contain upvotes and downvotes, and they must both be numbers, and this is what I received. So the reason I phrase it this way is because I'm kind of thinking about all the different things that could go wrong, right? Like we did before. So one thing that might go wrong is we just receive an empty object. So if we receive an empty object, what's going to happen on this line? So I heard it should fail because the input is undefined. So the upvotes and downvotes will both be undefined. So you're correct that they'll both be undefined, but it's not true that it'll fail. So when you go, let's pull open the node interpreter here. So this is an empty object, right? Foo is an empty object. So if I go foo.bar, I just get undefined. So if I try to put the value of foo.bar into another variable, it just puts undefined into that variable, right? So we just wind up with undefined, and nothing really goes wrong yet. In fact, if we subtract undefined from undefined, we just get not a number again. And that's the same boat we were in when we go what was it, 10? Right? It won't pass the check. Yeah, exactly. So we'll throw, oh, did you mean it would hit this error?
Yeah.
I see. Yeah, so it'll look at the value of upvotes and the value of downvotes, and it'll say neither of these are numbers. And yeah, it'll hit this error. That's right. So I'm imagining someone passing an empty object, or I'm imagining someone passing like a string, right? This particular example would be kind of silly, but you might imagine, okay, here's a more realistic example. You might imagine someone passing two numbers, or an array of upvotes and downvotes, right? And in any of those cases, you want to inform them that the input must be an object. And then yeah, we're describing that the object must look like this. It doesn't matter if it has other stuff, right? Like the post could have all sorts of other things. You could have a whole bunch of other stuff in the post. As long as it has upvotes and downvotes, the function will work, right? So that's what we're describing here. Another thing I want to show you is if you imagine a bunch of posts. Let's make them valid posts. How about? So now we have a collection of posts. We have an array of posts, right? We still want to compute the post score, but this time we're doing it on the whole collection. Let's try the working case first. Okay, so we get the score for all of our posts. If I wasn't so lazy, I would like make these different numbers, but now if we change one of these, let's say this one doesn't have upvotes for some reason. This is a malformed post object now. What do we expect to happen now? We're expecting not a number for the third one. So you think this will be not a number? Okay. Any other theories? How about from Calgary? 30-30 error. Okay. So we're gonna see. I think what Christina, or sorry, Christian means is I said Christina earlier too. Is that we'll see 30-30 and then it'll blow up. Yeah, and so it did. So this is like quite a loud error, right? So we got our, this is the line that went wrong. This is the line number. And then here we got our kind of verbose error message, and we see that we received undefined and 10. So that's kind of nice because we, without looking any further, we kind of know like, oh, I know what's wrong there. That's supposed to be a number and it's not. Maybe it's not in the object. But we can keep going, and now we can see that the stack trace contains more stuff. So this error occurred while we were in compute post score. While we were doing compute post score, we were in for each. And while we were in for each, we were in like the array prototypes for each, which is kind of a noodly technical detail. But we know that this occurred in a for each, and that we were trying to compute post score, and that's where everything went wrong. Yeah, so the last thing I want to show about errors is like, hopefully by this point you're kind of convinced that having extra errors in your app is a good thing. It helps you as you're developing to like use your own code correctly. It helps you catch things like when things are going wrong, when you're not building a post object correctly, for example. You can catch it rather than have it like, you know, pass not a number around your app and then you see it come out somewhere else. You're like, how'd that happen? You have like this huge code path to traverse. You see an error earlier on, and that lets you narrow down the problem like that. So that's great. But the fact is, we're going to be putting apps out into prod, right? We're going to be putting apps out in front of people, and businesses are going to rely on them. And if they just like blow up when something goes wrong, it's like maybe it'd be better for them to see not a number rather than, you know, the whole app blowing up, right? So that's where try catch comes in. There's another red word. Try and catch. So here's how try catch is formatted. You can actually. You have a try block. You know what I mean by block? Where else do we see blocks? What was that? Something to do with the squiggly things. Yeah, we see blocks marked out by squiggly things. So we most commonly see those as the compound statement that you put after an if. But you can just do blocks wherever. You normally don't though. You put them after if statements, or you put them in try catch blocks, or for in or for of loops. But yeah, so this looks a little bit like an if statement, right? Or like an if else statement. And in a way it kind of is. This is a flow control statement, just like if else. But in this case, it's not doing what if does, where you compare a predicate. You look at a predicate, like if, you know, if and then do some stuff conditional on this. The conditional for a try-catch block is built in. If an error is thrown inside this block, then run the catch block. And the implication there is that once the error is caught, it won't continue bubbling up. It won't reach the parent node process, and it won't crash the app. So if we take this try-catch, and we wrap our faulty for each in it, so crashes. That's confusing. Oh, I know why. Because, yeah, is anyone, what's that? Oh, okay. The question was, don't you return the error from the function? Not exactly, but the throw is a lot like a return in that when you're inside a function, there's like some other process outside of the function that's like listening to see what comes out. But instead of returning something, it throws an error. But it's the same kind of pattern of like coming back out of the function and saying, here's what happened. So you don't get to go like, and then get the error in here like you would with a return value. Actually, I guess you'd do that here. The error comes out here. So if an error is thrown anywhere in here, then anywhere inside this block, then it'll appear here. So it's like, in a way, it's sort of like if this block returns an error, then you receive the error here and you do something with it. And that error is only going to exist here, and then the app's going to keep trucking. You have a question?
I have a theory for why it's still true. Do you have to specify the kind of error?
You have to specify the kind of error. Yes, that's a thing, but that's not why it threw. Well, that's not why it stopped. So the reason, the thing I was expecting was for to see 30, 30, and then an error in the console, and then 30 again. So it'd keep running. But it didn't, because the error occurred inside of this block, but the for each is inside of the block, right? So as soon as an error is thrown, everything that's happening inside of the block stops. You bail out, yeah, you have to do the for each outside of the try catch, or put another way, do the try catch inside of the for each. So let's try that. Okay, good. So we get the first one works, the second one works, the third one throws an error, and then the fourth one works. Right? So the whole thing just keeps on running. And that's basically what try catch is for. You might decide while you're developing, these posts could come from some faulty API that sometimes just gives you bad data. And when they give you bad data, you want to make a decision. In this case, I made the decision, okay, I want to know what the error was. I want to know what the error was, but also I don't care. Like I don't want the application to care. I want to just keep rolling. Just ignore that one. But in the catch block, you might do some stuff where you actually you actually might have like a different plan. So instead of console logging, like in this case, we're just console logging the score, right? So we're console logging 30. I might make the decision that I'm not going to look at the error at all. The thing that I want to do in the event of like an error occurring in here is I just want to report that the score was 0. So now when I run this code, I get 30, 30, 0, 30. And that's maybe like a reasonable way to handle broken code. Yeah, you have your, this is what I'm going to try to do. If it doesn't work, here's my plan for coping. Does that make sense? Any questions so far about error handling? Okay, then we're going to take a 10-minute break, go get coffee and stuff, and then when we come back, we'll talk about promises.
Console log error. That's the error object, right?
Pardon me?
The error object.
Yes.
So it prints out something. If you're like if errors, most objects get like way to get it.
Yeah, exactly. So well, not necessarily every object, but let me put it this way. Every object is allowed to implement toString. In other words, this is what happens when you turn me into a string. So the way that errors do that is by printing out like the stack trace and stuff.
Console log always.
I think so. So if I go, let's say new date, we see a date appear in the console, right? And this is this is not really a string, right? It's like some kind of complex object with behavior and like all this state about like what time zone we're in and stuff like that. So if I go console log new date, then I get out that thing. I think that's like a special browser thing. I think if I do that in Node,
Yeah.
yeah. So this is a little different, right? Like this just kind of looks like a regular string. Yeah. So it's turned out to be pretty similar. Like what we're looking at here is not it's not a string, right? It's like if I console log that string, like it looks different. It's visually distinguished, right?
Yeah.
So this is a representation of the date. This is like the actual string that's being represented, right? So when we get a new error, we get this error object, and this is our stack trace here. So the stack trace is just one layer deep because we're in the REPL. But yeah, that's it. Cool, we're just about to get started again. Um, does it still work? Yeah. Okay, we're just gonna ease in a little bit while I wait for thumbs up from Calgary. While we're waiting, I want everybody to take a look at the code on the screen and think about how it works. Just sort of prime your brain with that. Okay, cool, Calgary's on board. Okay, I've been doing some doodling on the board. If I forget to change the screen over for Calgary, someone just wave at me, please. So we're still looking at the code for now. Who wants to talk us through what this does? What's going on here? Chooses a random diner and decides who gets the bill. Yeah, yeah. So that's a good kind of like outside looking in definition of what this is, right? So when we're talking about, if you imagine this wrapped in a function, we often want to talk about it in terms of like the business logic of what the program does, what the procedure does. And so that summary, which I'm gonna try to paraphrase you here. It selects a random diner to get the bill, and gives them the total including tax but excluding the tip. Make sense? So that's a good way to look at it from the outside looking in, which is often the right way to think about the functions that we use. That way of thinking is called black box abstraction. It's like, I don't know what goes on inside of this black box, but I know you put this sort of thing in and you get this sort of thing out. We're gonna dig in a little bit more, and notice that this isn't a reusable, programmable, parameterized function, right? This is just a procedure. This is just a list of steps, right? This is just like a checklist of like, first do this, then do this, then do this, then do this, right? And one of the things that I want you to start thinking about as we start talking about asynchrony and promises and things is dependencies. So what's a dependency? A dependency is when one piece of functionality relies on another piece of functionality, or a piece of data, or something. So do we notice any dependencies in this code? Pardon? The defined variables, sure, yeah. So these are important, right? If they're not there, the code doesn't work, right? So what happens if that's gone, if all that data's gone, what effect does it have downstream? Yeah, you get reference error. This thing tries to look at probably this is where it crashes, right? It tries to do this random index thing, and it goes reference error diners is not defined, right? So we bring back in diners. Now we can say that this dependency is satisfied, right? So line 9 has a dependency on line 3, we could say. Line 3 line 3 to 8. This statement here, what dependencies does it have? Line 10 to 14 here. What are its dependencies? The random index variable. Good. So yeah, we have this random index, so that needs to be there, right? How about diners? Diners needs to be there. So those two dependencies are satisfied right now, right? But it also has dependencies on the total bill, and there's no total bill, the tax rate, and there's no tax rate. So it doesn't work, right? Back when we were looking at our score computer thing, this function has a dependency on there being a post. And it also has a dependency on the structure of that post. It has to have upvotes and downvotes, and they both need to be numbers, right? That's a dependency that this function has. So dependencies are a big part of programming. And when you first start building software, you write a lot of scripts like this, right? It starts at the start and it goes line by line, works its way down the file, and as long as everything happens in the right order, we're good, right? It gets to the end and it exits, right? There's a name for that style of programming. Does anyone know what it is? Any guesses? Procedural programming. Yeah, exactly. This style of programming is called procedural programming. So we can describe this as a procedure, like the same as if you flipped open a guide to like starting a fire or something. It might have a procedure for like, first you prepare the site, then you gather your kindling, and then it has these like steps that you follow. And as long as you do them in the right order, you're good, right? But like the plan for starting a fire and the plan for like, say, running a business are sort of different, right? In the same way that the plan for doing this calculation, this discrete task of calculating a bill, is different than the task of supporting a web server, right? So as web developers, we care a lot more about web servers than we do about calculating bills. So we want to know, how do we solve problems related to web servers? Does anyone want to take a stab at description of what a web server is? A minimal description of how web servers work. What does a web server need to be able to do? Receive requests and respond. Yes, exactly. So how does receiving a request work? That's a hard question. Like a GET request, for example, yeah. Yeah, so one way is by programming, like you have this plan for, I'm going to receive basically text, right? That's how HTTP works. It's just like a blob of text. The text is going to have like a certain format, and one of the things in that text is going to be the route, right? And I have a plan for when I receive a request, I look to see what the route is, and then I do some stuff based on which route was asked for. So there's the implication there that the web server is listening for requests, and the way that works in practice is you just have this infinite loop that goes: is there a request now? No. Is there a request now? No. Is there a request now? No. That happens like hundreds, thousands of times per second. And then when a request comes in, it goes, oh, and then handles it, right? So how do you do that in the procedural paradigm? How do you take this guide to starting a fire sort of plan where you just run the script and it goes line by line, gets to the end and exits? How do you make a web server with that? It's kind of hard to rectify these two ideas of the thing that this file is an example of is a discrete procedure that starts, does its thing, and then ends. And your description of a web server was about something that reacts to outside events, right? So those are sort of two different paradigms. Your thing is asynchronous. The web server is asynchronous. In other words, when you start running the web server, there's a bunch of the work that it doesn't do when the web server starts. It only does it when there's some outside input, right? And nested inside of, sorry, let me take a step back. So we have all of these behaviors. If you get to /users, I expect to get a list of all the users, for example. There's a bunch of imperative procedural stuff that you can imagine happening in response to events, right? Like you could conceivably have a route that's like bill / this is not RESTful at all, right? But like you could imagine having some bill and then you randomly assign it to some users, right? And then while you're handling that route, you run code that works exactly like this, right? So in other words, there's some event, right? This describes an event. Some event that when this happens, we're going to do this. Right? So do you kind of see how there's sort of like two different ideas going on? Like when we're talking about route handling, we can have a bunch of routes here that are like app get. You can have a whole bunch of routes that in route handling land, all I did here was collapse. I think text collapsing, text folding is like really handy. Talk about that a little more. But this text folding lets me look at this at like kind of like the setting up my route handlers level. And like these things don't have dependencies on each other, right? It doesn't really matter. Like it's not incoherent for me to put users before, like the route handler for users before the route handler for randomly assigning bills. Like there's no relationship there. But then here, if I just zoom in on this imperative code, it's like a different plan. It's like a different concept. Now we're back to the idea that this line has a dependency on all of these lines. Right, we're back to that. So that's hopefully a not too abstract primer on the difference between asynchrony and synchrony. Synchronous programming and asynchronous programming. Any questions so far? Okay. So when we're talking about promises, if at any point I get off on some like philosophical tangent again, I'm not going to stop. You can't stop me. But when you're kind of like, yeah, okay, but like what, like how does this apply to like what I'm doing? Promises and asynchrony basically deal with when you're handing off control to some other process. Okay, promises and asynchrony pertain to handing off control to some other process. So in practice for web development, that's almost always going to be an API call, like a request to some other server, or a database query. So in the case of an API call, what you're doing is you're handing off control to your networking, and you're going to ask some other server that you don't know anything about. It's going to send you back a response. And you don't know how long that's going to take. It could be like a person sitting at a terminal typing out a response for you, right? Most web servers don't work like that today. But you're handing off control to some other process, and you don't know when it's going to come back. In the case of a database query, it's probably your backend is making a call to, it's using some database driver, like your PG module, your Connects module or something, is handing off control to a Postgres instance or MongoDB instance, and then MongoDB is in charge, for example, of deciding when and how it responds. So promises are about dealing with that. Promises are about dealing with this, with this let me know when you're done kind of pattern. Yeah. So I made an app. You guys want to see it? Okay. My app's called Good Words. There it is. And all Good Words does is you type a word. Does anyone know any words? The word word? You can't use word. It's already taken. I'm gonna demand a little more creativity. Inconceivable. I get that right? Okay, cool. Can we get a word from Calgary? Can Calgary send us a word? Thank you, Greg. Okay, so this is all that the app does. This is the whole thing. But I built this to illustrate a few things. The first thing that it does is it shows us a little bit about how user interfaces work. And some of this is going to be review. You've already been like building interfaces. You've already been making AJAX requests. That's amazing. Good for you. So some of this is going to be review. But we're going to talk a little bit about how to build this sort of thing with promises, and also how to think about asynchrony maybe in a different way. So we have a user interface. We have this button. And what's the button doing? Any guesses? How do you suppose this button works? You press it? Is that what you said? Oh, it's making a request. Sure. More interesting answer. Yes. It submits a form, says Calgary. So let's see what happens. Can I get one more word from Vancouver or Calgary, either or? Just so we can see what happens. We need a word to continue the lecture. Button, okay. So when I click that, is this big enough to see? We made a GET request. So yeah. So the idea that it submits a form is plausible, but turns out to not be what I'm doing here. But But one of the effects of submitting a form, if it was submitting a form, it would work basically the same way, right? So we make a request to /words/button, and we get back a response. And the response is this like huge, big JSON thing. And that's actually not even all of it. I don't know where the rest of it, I guess the rest of it is kind of like hidden behind these ellipses. But yeah, the Oxford Dictionary API actually like sends back like this like huge blob of like there's so much to know about the word button. And I basically just parse it down to the definitions. So there's a click handler here. And this is the whole front end app. And you can see that the text is folded. Right? So there's a bunch of stuff hiding here. This is hidden behind ellipses. Right? So when I'm looking at a new app, I like to sometimes just like fold up all the text and see what it looks like at the top level. So we can see that I have this button. I set up a click handler on the button. And so the button does something when it's clicked. I have a function for handling the response from Oxford. I have a function for rendering a word definition, and I have a function for handling the loading. So notice when I do does that little loading thing while it's loading. That's handled there. And request animation frame, if anyone wants to do like some serious animations or like make a game or something, come talk to me about request animation frame later. That's just related to the loading thing. So let's see what this click handler does. What I'm doing here is I'm setting up a behavior. I'm defining an asynchronous behavior, right? So what we don't want is for the page to load and then this function runs. Right? What we want is for this to wait until somebody does something. Somebody takes an action. Somebody, in this case, clicks a button. So in this case, this is just related to my loading thing. This gets the value from the form. And then I make a fetch request. Has anyone played with fetch before? Okay, this is where we're going to learn then. So fetch is great. It's an API that's built into the browser. So you can use it anywhere. You don't have to import anything. And you use it for making asynchronous, you use it for making AJAX requests. And the interesting thing about fetch, like the cool thing, and the reason it's in this lecture, is that fetch uses the promises API. So we're going to look at this in the console, and that requires spinning up another route. Let's do camel case. I prefer camel case. Let's do... Let's make sure the server has the new thing. I don't think I'm using NodeMon in this project, so I just restart the server. Now if I go to 8080, make sure that still works. For some reason, my Firefox hangs when I load up an Express server. Firefox hangs, and I go to Chrome, and I go, and it loads. And then usually I can go see Firefox, and then Firefox loads. I don't know what's up with that. If anybody figures it out, please let me know. So yeah, what was that route called? Favorite word. Okay, cool. So I just spun up a new route. That should be like, right? That's easy for everybody here, right? Lots of new routes going on. I get a JSON response with my favorite word. So I want to talk about how to do that with fetch. So fetch is pretty easy. I'm just going to go fetch. Then the URL. And boom, there I go. But this is a promise object. That's not the word I wanted. That's a promise. Maybe if I put it in a variable. Excuse me. So yeah, I still got this promise object. So you'll notice the difference between when I did it here and when I did it here is that the state goes from pending to fulfilled. And that's probably, I don't know, is that surprising to anybody? Does anybody have any theories about why when I do it here, when I do it this way, why this one's pending and this one's fulfilled? Okay, so promises basically have three states. They have pending, I'm not done yet, fulfilled, I'm done, and rejected, something's gone wrong. But the key insight here is that a promise is like this object that you can't really like get at the insides of. You shouldn't really want to necessarily. A promise is like a unit of encapsulation. So the plan for using promises is to use a promise. You only need to know one thing. It is a promise. Every promise works the same way. So if you ever get something back that says promise, you know how to use it, or you will by in the next 15 minutes. So fetch. We know it's a promise, so we know that we can do something after the promise is fulfilled. And the way that we describe that is with .then. Can you guys be a little quieter? We're still in lecture. So let's see what the result is. Now we get a response object. That's a little closer. So fetch does this thing where once you get the response, it gives you this response object because you might want to do some internet engineering on it. In practice, what you really want to do is just ask for it in JSON format. And there's our data. Who's impressed? Anybody? Okay, I think that's pretty cool. So what's happening here? We have, we do our fetch. That makes an API request. Then we say, thank you for the response. I'd like that in JSON, please. Then we hand it off to console log. So this, in the same way that in procedural programming, we have this well, if B depends on A, then A needs to appear earlier in the script, sort of thing. That's how we do our dependencies. In promise land, this is how we do our dependencies. If this console log needs to know about the response to the fetch request, it has to come later in the promise chain. And that way we can write things kind of like in whatever order we want, but then when we put them in a promise chain, we can enforce like a particular order of operations here. So the paradigm shift here is that we're not really ever doing like with promises, we're never really going into promise land and then pulling the word out and then using it. What we're doing is we're taking any of the behavior that depends on this promise, that depends on the result of the database query, or depends on the response from the API. We're capturing that dependency inside a .then block. We can call this whatever we want, right? And what's cool about promises is that when we wrap everything in .thens, it's really easy to move them around, right? So I noticed that I skipped that thing that I said earlier about you have to ask for it in JSON first. It's like a weird fetch quirk. So, but because it's like this kind of unit of behavior is wrapped up in a .then, it's really easy to just slide another .then in here. And then if I want to do like some error checking or make some other request, right? I can just pop that in another .then. And each of these will chain like one to the next. And every time one of these finishes, the thing it returns becomes a promise. So this can be another fetch request. This can be just like a string. It doesn't matter. It just gets, because it's inside of a .then, it just gets handed off as another promise. So rush through that a little bit because we're kind of running out of time here. But do you have a question?
Yeah. Is it the same promise object, or is it modified, or is it a completely different promise object?
Is it the same promise object, or is it a modified version of the promise object, or is it a completely different object? Was the question. Good question. It'll be a different promise at the end. Each .then will return a new promise. So one way that you can use promises that I think I have an example of, which would be great. Request. Yeah. So what I'm doing here is I have this function that I know returns a promise, right? So I wrote this one myself. That's how I know. So down here, I have, these are like some HTTP options, and then I make this is just a library that makes an HTTP request, and it comes back as a promise. So I know that this function returns a promise. So I also know that this function returns a promise, which means that I can call .then on it. So because responding with the definition of a word has a dependency on Oxford Dictionary giving me back a word, I don't respond to this API endpoint until this thing's finished. Does that make sense? And that's not an answer to your question yet, but does that make sense so far? Okay, cool. So when this is finished, it returns a promise because this thing returns a promise. So in that way, we can tell. No, you know what? I just realized that's a bad example of an answer to the question you're asking. So never mind. But let's say I did something like, I have this code over here in the front end that does this like parsing of the response. So if you suppose that I brought this over here, this is just like synchronous code, and it's going to return like an object. It's not going to return like a promise or anything. And yet this .then block is going to receive a new promise. So it's not going to be this promise modified. It's going to be like the object that this it's going to be the object that this thing returns, just like wrapped in a new promise. So that pattern extends to well, everything you use promises for. It doesn't matter what the .then returns. It just wraps that thing in a new promise and then gives you that. Yeah, it's not a nested promises thing exactly. It's like you're always just like handing one promise off to the next thing, right? Which is like a lot better than the callback paradigm, where like each callback can have like whatever sort of interface it wants. Like it can take different parameters, it can have different return values, whatever. The nice thing about promises is that if you know something's a promise, you know exactly how it works. It works the same way every time. You call .then on it, you call, you can chain the .thens, and then do the thing you want at the end. So it always works the same way. It doesn't matter if it's like a database driver, it doesn't matter if it's Ajax library, like, or an Ajax tool like Fetch or Axios. I think you're going to learn about Axios in React Week. It always works the same way. You just call .then on it and then look at the result. And if it's not the thing you want, you just return that and then have another .then and do the processing you want, and then you look at it again and you're like, yep, that's what I want. Then you do the thing you want with it. Does that make sense? Okay, we're kind of at the end of the lecture. As I said, I know I kind of rushed through the end there. Are there any points of confusion? Is anyone just so baffled that they don't even know what to ask? A little bit? Appreciate your honesty. Okay, well, I'm here for the rest of the day, so if anything comes up that, like if something clicks and you realize, you know, what you're baffled about, let me know. And I'd be happy to go in more depth with any of you. Any other questions before we wrap up? Okay, thank you, everybody. Hope that helps.